Here, I have a machine that needs to be designed, a gumball machine. It dispenses one gumball after 8 cents is inserted. It only takes pennies and it does not return change. So first, I'm going to create a mealy design for it. And for the state diagram, I'm going to create 8 states, one for each cent that the machine could be in. So now I have my 8 states, and I've labeled them A through H, and each one is also labeled with the cent state that it represents, 0 through 7. Since this is a mealy machine, we don't have an 8-cent state, because as soon as it goes from the 7th state and receives one more penny, it'll go put out a high output, and it'll go straight back to 0. And now I'm also going to use a binary label on each of these states. Each of these binary codes is really just the cent value, but in the binary form, I guess, which just so happens because we need 8 cents to get a gumball. Now I'm going to put arrows for each value of x, or whether they're putting a penny in or not. So x will equal 1 or 0, the input. So here's our final state diagram with all our arrows in place for each input. Whenever the input is 1, so 1 cent is entered, then it moves on to the next state. 0 cents to 1 cent, 1 cent to 2 cents. And when it finally gets to H, 7 cents, and another cent is entered, then it goes back to 0 cents. And this is where the output is high. We get a gumball. If it's ever 0 cents that's entered, and input of 0, then it just stays in the same state. So now we can make this in a more state diagram as well. So this is my more machine, essentially the same. Still have 8 states A through H with the 0 and 1 inputs, except that we have an extra state, G. This represents 8 cents. So from 7, instead of going to 8, if 7 receives an input of 1 cent, it'll go to 8 cents. And then whenever the clock cycle, another cycle goes by, whether the input is 0 or 1, we'll still get a gumball. So G produces a high output either way. 0, it goes back to A, and if it receives a cent, then it'll go straight to state B.